You walk outside tonight. You find a quiet hill, away from the city lights, away from the noise, and you look up. What do you see? You see darkness. You see a vast, deep, velvety black ocean punctuated by tiny pinpricks of light we call stars. It is beautiful, it is poetic, and if you trust your intuition, it makes perfect sense. The sun is down, so it is dark. Simple. But I am here to tell you that your intuition is wrong. In fact, that darkness you see is one of the most disturbing, confusing, and contradictory observations in the history of science. If the universe were the way we thought it was for 2,000 years, if it were the way Isaac Newton thought it was, the sky should not be black. It should be white. I don't mean it should be a little bit brighter. I mean that every point in the sky, every single pixel of your vision, no matter where you look, should be blazing with the intensity of the surface of the sun. The night sky should be a wall of fire. It should roast you alive in a fraction of a second. The fact that it is dark, the fact that you are standing there shivering in the cold instead of boiling, is a paradox that kept astronomers awake for centuries. Why is the sky dark? The answer to that question requires us to dismantle the entire universe and put it back together. It requires us to understand that we are not living in a static painting, but in a terrifyingly dynamic explosion. So, let's take a look. Let's play the game. Now, before we get to the solution, we have to understand the problem. Why on earth would I say the sky should be bright? That sounds ridiculous. You look up, the stars are tiny. There is a lot of empty space between them. It's obvious why it's dark, isn't it? Well, let's think about it. Let's use our imagination, not equations. Suppose you are in the middle of a very thick forest, a limitless forest, trees everywhere. You look around. What do you see? You see tree trunks. Now, look further. Between those trunks, you see more trunks. And between those, even further away, more trunks. If the forest goes on forever, no matter where you look, your line of sight will eventually hit a tree. You might have to look very far, but eventually, thwack, you hit wood. If the forest is infinite, you cannot see the sky. You only see a wall of wood. Now, replace the trees with stars. If the universe is infinite in size, and if stars are scattered roughly evenly throughout it, and if the universe has existed forever, then every line of sight from your eye must eventually end on the surface of a star. Every single one. You look at a patch of dark sky? No, you just aren't looking far enough. If you waited for the light to get here, or if you had a telescope strong enough, you would find a star there. Therefore, the whole sky should be covered in star surfaces. And since a star is hot and bright, the whole sky should be as bright as the sun. You might say, wait a minute, Richard. The stars that are far away are dimmer. They aren't as bright as the sun because of the distance. That is a very sensible objection. It sounds right. But let's check it. Let's be honest with the geometry. Yes, the light from a single star drops off. We know this rule. If you move a star twice as far away, it looks 1/4 as bright. It's the inverse square law. The light spreads out over a sphere, and the surface area of a sphere grows as the square of the radius. So the light gets thinner, it gets weaker. But here is the trick. Here is where nature plays a joke on us. While the individual star gets dimmer, the number of stars increases. Imagine a shell, a hollow ball around the Earth at a certain distance. Let's say it has a thickness of 1 billion miles. We count the stars in that shell. Now, imagine a second shell twice as far away with the same thickness. Because it is twice as far out, the surface area of that shell is 4 times bigger. If the stars are scattered evenly, there will be 4 times as many stars in that second shell. Do you see what happens? The stars in the second shell are 4 times dimmer individually, but there are 4 times as many of them. The total amount of light coming from that shell is exactly the same as the first shell. Now add a third shell, and a fourth, and a millionth. Each shell contributes the exact same amount of light to your eye. And if the universe is infinite, if there are infinite shells, you have to add up infinite amounts of light. The sum is infinite. Or, practically speaking, it stops when the sky is solid light. So, the dimness argument fails. It doesn't save us. The math cancels out perfectly. It's like a conspiracy of geometry. This creates a serious crisis. Because Look around you. It is dark. So one of our assumptions must be wrong. Which one? Is the universe not infinite in space? Maybe. Is there an edge? A wall where the stars stop? That seems unlikely. Nature rarely builds brick walls in the middle of nowhere. Are the stars not distributed evenly? Maybe they are, clumped. But we look out with telescopes, and on the large scale, it looks pretty mushy and uniform. There is another possibility. People used to think, maybe there is dust out there. Maybe there are dark clouds blocking the light from the distant stars. You know, like smog in Los Angeles. If there is enough dust, it would absorb the light, right? No, that doesn't work either. This is thermodynamics. If you have a cloud of dust and you shine infinite light on it, the dust will heat up. It will get hotter and hotter until it glows just as bright as the stars behind it. The dust would become a light source. You cannot hide energy. You can only move it around. So the dust explanation is out. So we are stuck. We are stuck with a paradox that suggests we shouldn't exist. This brings us to something very deep about science. When you find a paradox, when you find a contradiction between your logic and your observation, that is the moment you should get excited. That is where the treasure is buried. That is nature telling you you are missing a piece of the puzzle. The piece of the puzzle we are missing is time. You see, in the old days, and I mean the days of Newton and even before, everyone assumed the universe was eternal. They thought the universe just was, it had always been there, ticking away like a perfect clock, forever into the past, forever into the future, an infinite stage for the drama of existence. But this darkness, this simple dark night sky, it whispers to us that this cannot be true. The solution to the paradox is that the universe has not existed forever. The universe had a beginning. This changes everything. It changes the rules of the game. If the universe had a birthday, let's say, some billions of years ago, then we are not looking at an infinite forest. We are trapped in a bubble. Light travels fast. It travels at a speed of 186,000 miles a second. That is very fast. If you turn on a flashlight, the beam hits the wall instantly as far as you are concerned. But the universe is big. It is surprisingly big. When we look at a star, we are not seeing the star as it is now. We are seeing the star as it was when the light left it. If a star is 4 light years away, we are looking 4 years into the past. We are looking at a ghost. Now, because the universe has a beginning, there is a limit to how far back we can see. There is a horizon. Not a horizon of space, but a horizon of time. Imagine the universe is full of stars, infinite stars, going on forever. But the stars only turned on 13 or 14 billion years ago. We can only see the stars whose light has had enough time to reach us. If a star is so far away that its light takes 20 billion years to get here, we can't see it yet. The light is still on its way. It is rushing through the vacuum, tearing across the cosmos, trying to reach us, but it hasn't arrived. It is like a letter in the mail that hasn't been delivered. So, when we look up at the night sky, we are not looking at the whole universe. We are looking at a small sphere, a time bubble of the observable universe. We only see the stars that are close enough for their light to have reached us since the beginning of time. And because this bubble is finite, the number of stars in it is finite, there aren't enough of them to fill the sky with fire. There are gaps, lots of gaps. And through those gaps, we see the darkness of the nothingness before the stars were born. So the reason the sky is dark is because the universe is young. Isn't that a strange thought? 13.8 billion years? Seems like a long time to you and me. But for the purpose of filling the sky with light, it is just a blink of an eye. The universe hasn't had time to wake up fully. Now, if I stopped here, I would be telling you a partial truth, and I try not to do that. I want to tell you the whole truth, or at least as much of it as we understand. There is another factor, a factor that makes the universe even stranger. The universe is not just young. It is moving. It is expanding. This is something we learned from Edwin Hubble. But the idea is built into the equations of relativity. Space itself is stretching. Imagine you are baking a cake with raisins in it. As the dough rises, the raisins move away from each other. But they aren't moving through the dough. The dough between them is expanding. If you were a bug sitting on one raisin, you would see all the other raisins moving away from you. And the further away the raisin is, the faster it seems to be moving away. because there's more dough between you and it to expand. This expansion does something very peculiar to light. Light is a wave. It's a wiggle in the electromagnetic field. It has a crest and a trough, like a wave on the ocean. The distance between two crests is called the wavelength. For visible light, this wavelength determines the color. Blue light has a short wavelength, choppy, fast waves. Red light has a long wavelength, lazy, rolling waves. Now, imagine a photon, a particle of light, leaving a distant galaxy and heading toward Earth. It is traveling through space, but while it is traveling, space is stretching. What happens to the wave? The wave gets stretched too. The space it is traveling through is expanding, so the distance between the crests gets pulled apart. It's like drawing a wave on a rubber band and then stretching the rubber band. The wave gets longer. If the wave gets longer, the color changes. It shifts towards the red end of the spectrum. We call this redshift. If the galaxy is very, very far away, the space expands so much during the journey that the light gets stretched all the way out of the visible spectrum. It becomes infrared. Then it becomes radio waves. So the light from the most distant sources in the universe, the light that would fill in those gaps in the dark sky, is being weakened. It is being tired out. Its energy is being diluted by the expansion of space. So we have two things working together to save us from being cooked. First, the universe hasn't been around forever, so there hasn't been enough time for light from the infinitely distant stars to reach us. Second, the space is expanding, stretching the light that does reach us, sapping its energy, shifting it into invisible colors that our eyes can't see. This leads us to a profound realization. When you look at the empty spaces between the stars, are they really empty? No, they are not. If you had eyes that could see microwaves, radar waves, the night sky would not be dark at all. It would be glowing. There is a glow that comes from everywhere. It is uniform. It is constant. It is called the cosmic microwave background radiation. What is it? It is the afterglow of the Big Bang itself. Imagine the Big Bang not as an explosion in space, but an explosion of space. In the beginning, the whole universe was hot, dense, and glowing white hot. It was a fog of plasma. Light couldn't travel freely. It was bouncing around like a pinball in a machine. Then the universe expanded and cooled. Suddenly, it became transparent. That trapped light was released. It started streaming across the universe. That light is still here. It is filling every cubic centimeter of space right now. It is raining down on your head as we speak. But because the universe has expanded so much in the last 13 billion years, that blinding white light has been stretched and stretched and stretched. It has been stretched by a factor of 1,000. It is no longer visible light. It is microwave radiation. It is cold fire. If you turn on an old television set, the kind with the big tube and the rabbit ear antennas, and you tune it to a channel that doesn't exist, you see that static, that snow on the screen. About 1% of that static is actually the cosmic microwave background. You are watching the Big Bang. You are watching the birth of the universe on your TV screen. So, is the sky dark? To our eyes, yes. But to nature, no. The sky is full. It is full of the oldest light in existence. We just don't have the biological equipment to see it. We are blind to the history of the cosmos unless we build machines to help us look. This connects to something very fundamental about how we perceive reality. We are trapped in our own scale. We live in a middle ground. We are not as small as atoms, so we don't see the quantum jittering, the craziness of the very small where things can be in two places at once. We are not as big as galaxies, so we don't see the bending of space-time or the slow dance of the expansion. We are stuck in the middle, perceiving a slice of reality. Think about time again. I mentioned the universe had a beginning. This implies something about the structure of time itself. We tend to think of time as a river that flows. The past is gone, washed away. The future is yet to come. The now is the only thing that is real. But in physics, specifically in relativity, we have to change this view. We have to think of space-time as a block, like a giant sausage. Yes, a sausage. Imagine a sausage that represents the whole history of the universe. One end is the Big Bang, the other end is, well, whatever happens at the end. When we experience now, it is like we are slicing the sausage. We take a knife and cut a thin slice. That slice is our present moment. All the spatial arrangement of the stars and you and me is on that slice. But here is the kicker. Different observers moving at